Good afternoon, everyone. My name is Tatsuo Ishii. Today I'm going to talk about low pattern recognition, which is one of the features defined by the SKL standard. First of all, let me introduce myself. I'm currently working for SRA OSS as an advisor. And also, I'm one of the committers of Postgres. Main contribution to the project is internationalization of Postgres. Then also, I'm working for small tools like pgbench and pgstat-tuple. And also, I'm managing external project called pgpro2. There are contents of this talk, today's talk. Because low pattern recognition is not a super famous feature, so I think I need to explain the basics of low pattern recognition. Next, I move to the topic of syntax of low pattern recognition, and then I'm going to discuss on the implementation. Currently, I'm working on for the feature, and finally, I will give you small demonstrations. Okay, what is low pattern recognition, or RPR? That is one of the features defined by the SQL standard. It allows to search for a sequence of rows that is, for example, time series data by pattern. The key of the feature is pattern definition. That is like this form. The first one is have a label. Actually, name is low price, which has a simple logical expression like price is lower than 100. Next one is a little bit complex because it has function previous. This is defined in the standard as well. It refers to the previous row in the sequence of rows. So it may be referred to the yesterday's price. The down is opposite meaning. So once this definition can be completed, we can define a pattern using pattern variables and regular expressions. By the way, low price, up and down are called pattern variables. So using pattern variables, we could define, for example, low price, up plus, down plus. The plus means that one or more matches. So we could, this pattern matches with a sequence of rows which satisfies each logical condition. RPR applications include probably the most famous one is searching for stock price fluctuation patterns. Then also it can be used detecting anomalous values and so on. So let's talk about the definition of low pattern recognition, which is first appear in the SQL standard 2016. In the standard, it is called as SQL/RPR. That is a relatively new feature because it appears in 2016. It sounds like a long time ago, but in the SQL standard world, this is called new, I think. And currently, there are very few implementations of this feature. I think the only implementation for now is in Oracle. No open source database has implemented this one yet. However, some analytics tools, including Torino, has already implemented RPR. Okay, let's see some examples of RPR. The first one is detecting patterns in a time series data. Here we see a blue line, which indicates the value and the time series. And here we can find at least 3 patterns. The first one is like a pattern of rising and then falling. Next one is just rising. And also we have falling and then rising. RPR can find each of the patterns. Let's discuss about the pattern of rising and then falling. Here we have a small table which holds company name, date, and the price of the stock price of the day. We could define the actual requirement like find sequences of rows of rising once or more, and then falling once or more. From this requirement, first we define row pattern variables. We have 3 row pattern variables, start and up and down. The meaning is same as already discussed. That is, start means that as true, and then this matches any row. This is the starting point of the pattern matching. The up means that the price is lower than previous price. It actually means that the price is greater than yesterday's price. Down has the opposite meaning. Its price is lower than yesterday's price. Once these pattern variables, row pattern variables is defined, we can define a pattern using those variables. That is start, up, plus, down. So using this pattern, we map the first row to the start variable, and then up, plus, and down, plus. These definitions can be expressed in this actual query. This looks like a little bit complex, but actually, red bold lines are new clauses for RPR. I will explain details later. Here is the result of the search. Blue background represents the rows matching the search pattern. The first group matches starting from July 1st to end at July 4th. We could see prices rising from 100 to 200, and then falling to 150, and then continue to falling to 140. Same thing can be said to the next group. This is the first example. Let's move to the next example. In this example, we detect specific consecutive events. This is a simple event table. We have alert time and alert messages. Using this example, we want to find events where warning messages appear consecutively within 30 seconds, more than 3 times. Similar to the previous example, we define, first of all, meaning of the requirement. Here, we define that 3 or more consecutive messages starting with warning appear within 30 seconds more than 3 times. From this definition, we first define clause like this. Here we have 2 row pattern variables. First one is start. In this case, this meaning that it means that alert message start with warning string, and then warning pattern variable means that this one start with alert message, also warning, and the matching rows must be happen within 30 seconds. Now, from these definitions, we can define pattern clause like this: start, warning, warning plus. Here we have two warning pattern variables. The reason why we have this is that we want to find 3 or more rows. This is the actual query. And this is the final result. As you can see, we were able to find matching patterns. In this case, consists of 3 rows. Okay, next we move to a different topic. In the standard, actually there are 2 types of RPR. First one is called R010, which implements row pattern recognition in from clause using new match recognize clause. And another one is R020. That is we are discussing on. It implements RPR in window clause. Actually, R010 and R020 has many common definitions. So I think the expression, power of expression is not so much different from among these definitions. Then you might ask why I wanted to implement RPR in window clause first. Because RPR needs to scan a set of tuples over and over again for backtracking. If we want to do in from clause, it is very difficult because there is no infrastructure to implement this for now. However, window clause already has this kind of infrastructure, and that is the reason why I wanted to implement RPR in R020. Also, if we could implement R020, then this must be the first example of implementation in the whole RDBMS world. That means, excuse me? Sorry.
So does that mean that Oracle only has the from clause version?
Yes.
So that means we would not be able to run any query that Oracle can also run. I mean, they couldn't run our queries and we couldn't run their queries.
Yeah, right. That's correct. This is an example query in R010. As you can see, this one uses match recognize clause after from clause. Other than this, the syntax is very similar to R020. Okay, from now on, I'm going to discuss on the syntax of RPR. This is a whole window clause syntax. The red bold lines are clauses are new to RPR. In these clauses, partition by and order by are same as window clause without RPR. No difference. However, measures and subsets are new to the RPR. Unfortunately, I have not implemented these clauses yet. And also, I have to admit that some of the sub-clauses are not implemented yet. This is the current status of the my implementation. First, I'm going to discuss on rows between current row. This one clause already existed in the existing window clause. The only difference is that in RPR, these two types of syntax are allowed. The first one is rows between current row and unbounded following. That means the frame must start at the current row and end with the end of the frame. The next one is similar to the one, but finished at the nth row. Next is after match skip close. This is new in window close. This one specifies where to start the next pattern match after first pattern match succeeds. Suppose we have the first pattern match which has a blue background. In this case, we have 4 matching rows. If we specify after match skip to next row, the next pattern match will start at the row of July 2nd, because this is the second row. And if we specify after match skip past last row, then the next pattern match shall start at July 5th. Because this one specified to skip the previous pattern matched rows. Also, the standard defines another syntax after match skip to first or last, and then pattern variable name. Unfortunately, I have not implemented this yet for now. Next one is initial or seek. If we specify initial, the pattern match should succeed only if when the first row of the frame matches pattern matching. This is the default. Seek is different from in that the pattern match succeeds even if the set of matching rows do not start from the first row. This has not been implemented yet. Okay, now we are going to discuss on the heart of the RPL, define clause and pattern clause. We already have seen some examples of define clause, like this: define variable name as such condition. Such condition must be a simple Boolean logical expression. Example pattern definitions include like these. Some of them we already see. We also have special functions called row pattern navigation operations only in define clause. We already have seen a previous function, which means previous rows. There is another function called next. Obviously, this has opposite meaning to previous. And also, there are a first and last function in the standard. For now, in the patch, I only implement previous and next. Other than these functions, there are some objects allowed to specify in the define clause in the standard. First one is a classifier. This special function returns a variable name which matches the pattern. And also in the standard, it allows to use aggregate functions and subqueries, but for now, they are not allowed in the patches. Next is pattern clause. This describes the pattern to be matched using the pattern variables already defined in the define clause. We already seen some example as well, like a pattern start up plus down plus. One interesting aspect of SQL standard is that if pattern variable, for example, A, is not defined in the defined clause, but if it appears in a pattern clause, it is regarded as A is true. This sounds a little bit strange, but actually the standard required this. So we can omit this kind of pattern definition in the defined clause. And in this slide, we are discussing on regular expressions that can be used in pattern clause. In the current patches, I only allowed to use plus and star, which means one or more rows or zero or more rows. Other than this, we have following regular expressions. They are not still implemented in the current patch. Our next topic is how to handle aggregates in the target list if RPR is used. Basically, the usage of aggregate functions in window clause without RPR is similar to the one if RPR is used. The only exception is that aggregate is only applied to the matching rows. This is a little bit difficult to understand, I think. So I will show you an example how these differ. Left-hand side is window clause using two window clauses. First one is W1, which is without RPR. And the count is defined for over W1 has an alias name count1. The count is alias name for window clause that has RPR W2. Right-hand side, we see the difference of count1 and count2. Count1 represents a number of rows in the frame. In the first row, starting with July 1st row, has 10 rows in the frame. So the count1 returns 10. And the next row, starting at July 2nd, has only 9 rows in the frame. So the count1 returns 9, and so on. On the other hand, count2 returns 4 instead of 10 for the first row, because there are only 4 matching rows in the frame. And we see that starting from July 2nd to July 4th, count2 returns 0. This means that these rows are skipped because of after match skip past row clause. Also, we see that fifth row returns count2 returns 0. This is different because of a different clause. That is, the pattern does not match with the fifth row, and so on. This is the difference between count function on window clause using RPR or not. Next, I'm going to talk about actual RPR patches. As I already said, this is implemented in the window clause. This one is proposed targeting for Postgres 18 for now. And you can see the URL here. If you are interested, you can download the patches and apply to the master branch. Currently, the patches are for parser, planner, executor, and tests and documents. So the patches are for nearly all systems of Postgres. If we exclude tests and documents, the heart of the patches, about 3,000 lines. I think this size is not too small, but also not too large, I expect. Then if we are interested in how current patch can do, I recommend to look into the regression test file, rpr.sql. You will find SQL statements that can be run by using RPR clauses. The next slide explains some of the implementations of current patch. This one explains how pattern matching using regular expressions are implemented. Suppose we have this kind of pattern clause and define clause, start up plus down plus. Suppose we have a small table, price is 100, 200, and so on. First, the RPR engine tries to match the pattern to each row and find the matching variables. First of all, start should match to all rows because it just defined as start as true. And up and down are different because up might be applied to some of rows, while other pattern down can be applied to different rows. So basically, we have multiple matching for each row. And next step is generate possible combinations of those matching. We could get something like, for example, all rows matching start, so we have start, 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 and so on. And we also might have start, up, start, and so on, start, up, and down, and so on. So the basically number of possible combinations are huge. And the next thing RPR engine has to do is search for matching combination from them using the regular pattern variable and the regular expression. In this case, we need to perform pattern matching, start up plus and down plus. If we apply this, we can get this result, start up, down, down. And also, the plus regular expression requires that to find the longest match. So we need to do the regular expression search for entire matching combinations. And finally, we find that the start up, down, down is the result. This is how RPR matching engine works. Now here is the future plans. As already I said, current implementation targeting toward Postgres 18, hopefully. But I think I need to enhance the patch in terms of memory consumption. So if I can do that, this for Postgres 18, maybe I can commit this one to the Postgres master branch. And after this, I would like to implement the rest of the features specified by the standard. For example, major clause and subset clause, and more regular expressions. That is why I would like to separate the implementation into steps that the current patch, I think, in my opinion, current patch has already enough functionality for many applications. if we want to implement whole of the specification into the patch, the number of patch lines will be huge. That means that we may not able to review the patch. So I would like to cut down the size of the patch so that the first version includes minimum functionality. Okay, let's move to the final topic, demonstration. In this example, I would like to find extreme hot days. You might remember that last summer is extremely hot, especially in Japan, I think. So first of all, we define extreme hot day. Actually, in Japan, there is an official definition of extreme hot day. A day whose maximum temperature exceeds 35 degrees Celsius, and that is 95 degrees Fahrenheit. Once extreme hot day is defined, we can define extreme hot days, which means that consecutive extreme hot days. The data used in the demonstration is from the government official data. I pick up some of the data for cities around Tokyo, shown in this map. For the demonstration, I created a small table which holds a city name, date, and the highest temperature and the lowest temperature. Here is the actual query used for the demonstration. The first query returns extreme hot days regardless of the consecutive days. Let me switch to the actual demonstration window. First query is to find the consecutive extreme hot days, as I already shown. This one finds extreme hot day, which means that the day must be consecutive and each temperature exceeds 35 degrees. Now here is the result of the query. As you can see, most of the duration field, which means consecutive days of extreme hot days, is 0. And you can see some of the meaningful result in some places, like Chiba City, the highest temperature is 35 and so on. And then the consecutive days continues 2 days and so on. But you might think that this is not so useful because most of the days are 0. This is just annoying, I think. To enhance the query, we can define a view for the query. The view is defined like this. This is very simple. Just add the query to view clause to the previous query. We now define the query view, and we can issue a select against the view like this. In this case, I limit the duration to more than 5 days. So we have this result. You can see the top of the result is Kofu City, which has a consecutive extreme hot days for 9 days. As you can see, Kofu was extreme hot in last summer, and so on. So as you can see, we can arrange the query using RPL like this to get meaningful results. So this is my end of the small demonstration. Let's return to the slide. Yeah, this is the last result of the demonstration. Okay, here is references for the RPL. First one is official definition of RPL in the SQL standard. The other is documentation you can refer to. As you might know, the official documentation of SQL standard is extremely expensive. So if you don't have money, just please refer to the rest of the documentations. For now, I recommend to look into the Torino document manual, which describes the future very well. So that's all my talk. Thank you for listening. Questions?
Yeah, I was just asking how this syntax gets decided, the semantics, when, like, I'm used to more like C standard where, you know, compilers implement extensions and then those get added to the standard when it seems like a ubiquitously good idea. But here it seems like it's this random syntax that nobody cared about for the last 8 years.
Oracle
Like,
implemented.
but what was it about the from in the window?
Oracle implemented half of it.
Yeah.
Yeah, right. Currently, Oracle has implemented one of the RPL, and I implemented the half of the RPL, so there's no interchangeability. But I think it's not so difficult to translate RPL 020 to 010 by using subquery and so on. I had to admit that you cannot migrate the exact Oracle query into Postgres using my patches, but the rewrite shall be minimum if you use subquery or with growth and so on.
But like, what was the motivation for this in the standard?
Motivation for to implement 020
Yeah.
for me?
Sure.
Yeah, I want to be the first one.
Okay.
And I'm not sure, but there is a possibility that once 020 is implemented, we could use that for implementing 010 by rewriting. I'm not sure, but I feel the possibility of that. Any other question?
There was one of the slides where you said you did not implement subqueries.
Yeah, I have not implemented subqueries yet.
Yeah, well, what does that mean? So subqueries where?
Here, you could see a low price as price is lower than 100.
Yes.
You can use subquery instead of 100. For example, just select 100. I don't know what does it mean. It is useful or not, but the standard requires that.
So the way you've implemented it is actually making a string with start, up, down, up, and then using Postgres' regular expression engine on it.
Yeah, actually, I do a little bit optimization. For example, I translate each string like low price and up or down into a simple one-character alphabet. so that we could use regular expressions engine in Postgres can be used.
Right, but doesn't that limit us to 26 definitions? Yeah, if you just use S, L, and U as tokens, I guess, in the regular expression, doesn't that just limit us to the number of letters in the alphabet?
There is a limitation. In that, currently we cannot use a number of total pattern variables must not exceed 26, like that.
Right.
Yeah.
Okay. And I seem to remember that somebody was writing a new engine just for this in some of your reviews.
No, I'm not implemented new engine.
But someone else did in the thread about this on Hackers.
Yeah, you are right.
Is there any interest in going that way, or are we going to?
In my understanding, the engine only implements regular expression plus part. So, in my understanding, it does regular expression that it does not use regular expression engine in Postgres.
Okay.
Are you talking about the alternative?
Yeah.
Regex.
Yeah, you are the author.
I'm not sure I understood the question.
What's the status of your NFA or whatever it was?
So the current status, honestly, is I switched jobs, and so I haven't had any time to put into it. I think it probably needs a rebase and like a question of, you know, which approach we want to take, because I don't think it's probably a good idea to re-implement regex engines from scratch, which is what I've done.
Right.
But at the same time, I think there are advantages to implementing either a recursive or an iterative regex parser. And so my hope that we talked about on the list was that we could implement enough to start noticing where possible seams are in the existing regex that Postgres already has, so that maybe we could cut that up and export APIs that we need from that regex engine and then use them. But I have no idea how viable that actually is.
Right.
Okay, let's continue the discussion.
Sure.
Thank you. Other question? Any other questions? No? Okay, that's it. Thank you for listening and the discussion.